So when we're talking about a function, we're talking about a group of numbers. It can be a graph, it can be a table, it can be ordered pairs. We can show it a lot of different ways. What you're going to be deciding today is if the function is just a relationship of numbers, a group of numbers, or if it's specifically a function. So we would consider something a relation if it's x, y values. They're all considered relations. And then functions are a specific group where each x value only matches to one y value. So it's a relation where each x value only matches to one y value. And we're going to look at all the different ways that I can show you something that's a function today, and then your classwork and your homework is just going to ask you to decide if something is a function or is not a function. Did I just stop presenting that to you? Yes, I did. Oops. So one of the easiest ways I can show you what a function is to use those XY tables that you're so used to from last year. And I can say, okay, I have a group of numbers where my x values are 0, 1, 2, 3, and 4, and all of my y values are 8. So that's like saying if I was graphing, I would be graphing the point 0, 8, 1, 8, 2, 8, 3, 8, and 4, 8. And if I was to look at this and just wanted to, if I want to decide if this is a function, all I have to do is look at my x values. So I don't care about what's happening to my y values. I only care about my x values. And I want to see if my x values repeat. So all I'm asking myself here is, do x values repeat? And when I look at that, I see I've got 0, 1, 2, 3, and 4. All my x values are different, so because all of my x values are different, this is considered a function. So as long as all my x values are different, it's a function. So all I had to do for that question is look, see if my x values are different. They are, so it's a function. It doesn't matter what happens to my y values, so even though all of my y values are the same, doesn't matter. If I look at the second one, I'm asking myself the same question. Are my x values different? Do my x values repeat? And I would say yes. I have lots of 8s, right? So because I have lots of 8s in my x values, this is not a function. Come on, go away. So that's all I have to check. No matter how they present, I'm just looking for, do my x values repeat? So I could give it to you another way, would be these little bubbles, and these bubbles are considered maps. They're just another way for us to kind of group the numbers or organize the numbers instead of using a table. All that this is saying is that when I have the point 1, the x value of 1, I'm also using the y value of 8. So it's like saying I have the point 1, 8. This one, 2 to 9, is like saying I have the point 2, 9. This one says 3, 10. But it also says...
Mrs. Zavo.
You can't see it?
No, I can see it.
Okay.
But, so if y repeats, it's still a function?
Yep, it doesn't matter. The y can repeat as many times as it can do whatever it wants. We don't care about the y value whatsoever. We only want to look at the x value.
Okay.
Okay. And this last one, right here, says 3, 11. So the maps aren't as common for us to see when we organize numbers. They're because they take a little bit more time to draw it out, draw the arrows, make the circles. But just in case you come across one, it's just a kind of a fancy way of showing the ordered pairs. So if I look at this first map, do any of my x values repeat? I've got 1, 2, 3, and 3.
Yeah. 3 repeats twice.
3 repeats twice, right? So that means that this is not a function. So if it helps you, you can write these out as ordered pairs and then check the ordered pairs. Or if you notice that the arrow coming out of 3 was going to 2 different y values, that's enough for you to notice that this is not going to be a function. You don't actually have to write out the points in order to decide. But if it helps you decide, feel free to write out the points. If you can look at this and you notice right away that there are 2 arrows coming out of one number, that's enough to say this isn't a function. So if I look at this second one now, see how from -1 I'm going to 4, 3 is going to 15, and 11 is going to 15. If I was going to write these as points, I'd have -1, 4, 3, 15, and 11, 15. So because all of my x values are different, this is a function. Even though the 15 shows up twice, doesn't matter because we have -1, 3, and 11 are all different. The y value doesn't matter. Are you okay so far? Cool. I think the easiest way that I can give this to you is if I give you just ordered pairs and ask you to look at them because you're used to doing that the most. Here, I'll leave that up a little bit. So if I just gave you ordered pairs and I said, okay, look at the first example, says -2, 5, -1, 8, 0, 6, 1, 6, and 2, 7. All you want to do is look and see, do any of your x values repeat? And if I'm looking at all my x values here, -2, -1, 0, 1, and 2, right away I notice they're all different, so that tells me that this is a function. If I do the same thing for the second example, I've got -2, 1, -1, again, 0, 1, and 2. So I notice I have a -1 in 2 separate points, so that means it's not a function. So basically, if your x value repeats, then it is not a function. If all your x values are different, then it is a function. So anytime you're just given groups of numbers, you're just going to look to see if they repeat. the trickiest way I can give this to you is if I give you a graph and ask you if it's a function or not, because the graph is just going to have some kind of line on there. It's not going to actually have a list of numbers. So for a graph, we use what's called the vertical line test in order to decide if a graph is a function. So this helps us decide if a graph is a function. And the way we tell this is we look and we say, okay, if I draw a vertical line, so if I draw a vertical line through the graph, and it only touches the graph once, then it is a function. So if I can take my pencil and physically draw a vertical line, and remember vertical line is this way, up and down. If I can draw a vertical line through the graph and it only touches the graph once, then it is a function. So see how with this first one, as I draw a vertical line, I'm going to touch this point and I'm going to touch the next point. I end up touching here and here with the same vertical line, so this is not a function. It doesn't matter that all of these other points are on their own vertical line. Once I have just one spot that fails the vertical line test, that's enough to tell me it's not a function. So it doesn't have to happen for the entire graph, it just has to happen somewhere for it not to be a function. Whereas, like the second example, no matter where I draw a vertical line here, everywhere that I draw one, it only touches the graph at one place, no matter where I try to draw my vertical line. So since I can draw a vertical line anywhere there and it will only touch once, this is a function. So I think that's probably the trickiest part, because looking to see if the x values repeat is relatively straightforward, but checking the graphs and drawing the vertical lines is a little bit trickier. So I think I gave... You just want to make sure when you're drawing your vertical lines, something that wouldn't be a function. I could do an example would be if I had a graph and my graph looked like this. When I go and draw my vertical line through here, it touches the graph twice. So this is not a function. Does that make sense? Okay.